All right, so in this video, what I want to do is show you how to solve a quadratic equation. And I'm going to do that showing you 3 different ways. But I want to also kind of explore to you why factoring is one of our main techniques that we like to use for solving quadratics. So before we get into factoring, let's go into something very basic that we have here. In this first example, I have a linear equation, 4x minus 1. Now, when we want to solve an equation, linear equations, typically the first thing we learned is to use our inverse operations, right? To undo what is happening to the variable. So in this case, you can say I have a 4x minus 1. That means my x is being multiplied by 4 and subtracted by 1. So to apply my inverse operations to solve for x, I'm going to add a 1 to both sides, right? Use your inverse operations and then operations of equality. And then I'm going to divide by 4. So therefore, I get x equals 1/4. And most students, once they kind of get the hang of it, they're like, all right, I understand inverse operations. I can kind of follow that step by step, right? And then we move into our quadratic equations. And in this case, you can see it's basically the exact same equation. I just now raise the power of my variable x. Well, the nice thing about this equation is we have only one x. So we can still follow our inverse operations, meaning I can just add a 1 to both sides. And then I have a 4x squared equals 1. I can divide by 4. And therefore, I get an x squared is equal to 1/4. Then I introduce the square root, and x equals a plus or minus. Make sure you have to include the plus or minus. I will talk about that in just a second. And that's going to give you, now we can break up the square root using our rules of radicals. And therefore, that's going to give me a square root of 1/2. That's going to be a plus or minus a 1/2. Now, some people might say, well, why do you have to do the plus or minus? Where did that come from? And I'll go ahead and talk about that here in just a second over here. All right, but the main important thing is there's a difference here. It's being raised to the power of 2. Now let's go and take a look at this third equation. Now this third equation, we can't use our inverse operations anymore. And the reason why we can't use our inverse operations is because we have more than one variable. If you only have one variable, you just undo what's being applied to the variable. But which variable are you going to choose to do, right? And sometimes students will get this confused. They'll add the x to the other side. They'll maybe try to take the square root of the x, or they'll divide out an x. And we can't do that, because when we do that, what's happening is we're losing a solution. And the point that I want to bring to you is the fundamental theorem of algebra tells us that these equations are going to have the same number of solutions, real or complex, depending on where you're at in the studies, as the power or the degree of this polynomial. So when you have a quadratic, there's 2 solutions. That's why we have this plus or minus. Or it also could repeat it. I don't want to get above the context of the video. Another way we can look at this is to use what we call factoring. Right? I could use my inverse operations, but hopefully some of you also recognize this to be a difference of 2 squares, meaning I can rewrite this as a factored form of 2x minus 1 times a 2x plus 1. Then, once you have it in factored form, notice by factoring, what I did is I rewrote the expression as a product equal to 0. When you have a product equal to 0, now I can set each product equal to 0, and then I can use my inverse operations. So therefore, I add a 1 or subtract a 1, and then I get a 2x equals -1, divide by 2, x equals -1/2. And you can see that's where one of my solutions are. And here would be x equals 1/2, right? Add 1, divide by 2. So again, you can see if I would have done this by factoring, I would have had 2 solutions. So it's very important if you're going to use your inverse operations and you recognize this to be a power of 2, a quadratic, that you're going to be looking for 2 solutions. So therefore, that's why we have to include that plus or minus. Let's go and take a look at this next example. So this next example says 4x squared minus x equals 0. Well, again, we can't use our inverse operations. So again, what we're going to want to do is look to factoring. Just like I did over here with the difference of 2 squares, what I want to do in this case is looking to say, all right, how can I factor this? And basically factoring is just rewriting an expression as a product. A lot of times what we want to do is, you can think about that is just dividing out a common term. Look for things that they have in common. And in this case, you can see they both have a common factor of x. So if you divide out an x, what you're going to be left with is a 4x minus 1 equals 0. Now you can see that you can always check your answer by multiplying your variable back. So x times 4x is 4x squared. X times -1 is going to be a -x, right? So you can always check your answer on factoring. But now I have a product equal to 0. So just like I did over here, I can set my product equal to 0, because again, if you have a product equal to 0, then one of these has to equal 0 to make the equation true. So therefore, I just set both expressions equal to 0, and now I can just solve. And therefore, I get my 2 solutions of x equals 0 and x equals 1/4. Now, what about if we need to solve a quadratic where we have more than one variable, right? We can't use inverse operations, and we don't have anything in common. So we can't factor out any of our common terms. We're going to still want to look into factoring first, but we can't factor out a common term, our GCF, like we did over here. So what we need to think about in this case is understand, well, how can we rewrite a trinomial as a product? And hopefully up to this point, you've had a little bit of experience with rewriting this as a product of two binomials. You recognize when you have a product of two binomials, where as long as they're not the difference of two squares, these are going to multiply to give us a trinomial. We have a couple options here because our first two terms could give us a 4x, right? So our first two terms could be a 2x and a 2x, or they could be a 4x and an x. Now, you could do this a couple different ways. You could use what we call like the AC method and kind of identify what two numbers multiply to give you a times c, which is 4, and then add to give you a -4. And sometimes you might be able to look at this and recognize that that would be a -2 and use that method. But in my opinion, what I like to do is to look at this and say, all right, the first two terms always give us our first term in our trinomial, and the last two terms are going to give us a last term in our trinomial. Well, the important thing here is we don't really have any other options, guys. What two numbers multiply to give you +1? It's either +1 and +1 or -1 and -1. If your middle term is negative, your inner and your outer, so when I multiply my inner and my outer, those are going to add to give me my middle term. Well, if my middle term is negative, that means those two terms are going to have to both also be negative if they are going to be the same sign. So therefore, my only options here is -1, -1, -1, -1. However, what you recognize here is if I were to multiply these two, that gives me a -4x, and this gives me a -x, which gives me a -5x. Whereas here, when I do multiply my inner and my outer, I get a -2x and I get a -2x, okay? Now, here is kind of comes into that point that I was talking about. So now I have a 2x minus 1 times a 2x minus 1. If you think about this, you're going to get the exact same answer, right? So you're only going to get one answer. But the important thing that I want you to see is this answer got repeated, right? And we call that the multiplicity when we're looking for that. So it still satisfies our fundamental theorem of algebra with being a power of 2. It just, what happens is it's the same answer, it just gets repeated. Now, another way we could look at this is we could also rewrite this expression as 2x minus 1 quantity squared equals 0. So now I have one variable. So what I did is I took this equation and I compressed it, or I took this trinomial, refactored it, and then rewrote it as a binomial squared. And now what I can do is just use my inverse operations. Now, the cool thing about inverse operations for 0, it's just going to be plus or minus, with 0, which is still just 0, and then x equals 1/2. So a couple different ways you can go about that problem there. So let's go and do another factoring technique here. And again, take a look at this, my AC. Let's look at how to be able to do this maybe if we get stuck, be able to factor this. Maybe this factoring in my head didn't really work out for you. So another thing you can do is what we call the AC method. And you can multiply your first two terms, a times c, which gives us a -4, and then you can add them to your -3. And then we just ask yourself, what two numbers multiply to give us a -4, but add to give us a -3? Well, hopefully you recognize that's pretty easy, -4 and a +1. So those are basically what's going to break apart my middle term. So I can say a 4x squared minus 4x plus x minus 1 equals 0. Now, up to this point, what we can do is we can just factor this polynomial by grouping, or this quadratic by grouping. So we can group the first two terms, factor out the common elements, which is a 4x. When you factor out a 4x, you're going to be left with an x minus 1. And here you could factor out a +1. That'll leave you with an x minus 1. Now you can factor out the x minus 1, because those are the common factors, right? Going back to your GCF. And that's going to leave you with a 4x plus 1 equals 0. And now you can apply the zero product property. And therefore, x is equal to 1, and x is equal to a -1/4 when you subtract the 1 and divide by the 4. You could also do this in your head. You could have also identified this factoring by here, because these two numbers multiply to give you 4x. +1 and -1 gives you a -1, right? One has to be positive, one has to be negative. And then again, remember my inner and my outer need to add up to give you a -3. So if the little plane back and forth, hopefully you can go ahead and be able to work on those to be able to do those in your head as well. All right, so let's go and take a look at the last example. And the last example is one that I perfectly chose that is non-factorable. So you could sit here all day and try to identify what two numbers are going to multiply to give you that 4x squared, and then, or multiply to give you the AC method to give you this -4 and add to give you -4. But this on purpose is not going to be factorable across our real numbers. What we're going to want to do here, and again, you could even check this out. Like if you think about this, like what two numbers multiply to give you -4, add to give you -4? well, that's not gonna work, right? At least in our real number system. What we're gonna do here is another technique we used when we can't use inverse operations, when we can't use factoring, right? AC method or just factoring in our head. Now what we're gonna want to do is use the quadratic formula. So remember, a quadratic formula is when you are in standard form. And now what you're simply going to do is this is just a way to be able to find any of the solutions. Doesn't matter if they're going to be real, irrational, or complex. So opposite of b, plus or minus. Remember that plus or minus, that's the reason why, right? Because we know we're only looking for this quadratic formula, so we have to have that plus or minus. So this is where it's going to be a b squared minus 4 times a times c, all over 2 times a. So x equals opposite of b, so that's going to be a positive 4, plus or minus, let's see, that's going to be a 16 minus 4 times negative 1. 2 times a, which is 4. So that becomes a 16, and that becomes a, let's see, 4 times 4 is 16, but that becomes a 32. So x equals 4 plus or minus the square root of a positive 32 divided by 8. So now we can just leave our answer like that. However, we could go ahead and simplify that a little bit further. You could reduce this, so you could rewrite this as a 4 plus or minus. You could break up the square root of 32 into 16 times 2. So therefore, that would be 4 square root of 2 divided by 8. And therefore, we get a final answer of 1 plus or minus the square root of 2 divided by 2. So there we go, ladies and gentlemen. That is how you solve a quadratic equation from going through inverse operations to factoring all the way to the quadratic formula. I hope you enjoyed. I look forward to seeing you in the next video.